Hey class, so in this presentation, we're going to get into series parallel circuits. So these circuits are a combination of series circuits and parallel circuits. If you don't remember or don't know the laws for series and parallel circuits separately, make sure you go back and you review the laws, the 3 laws for series and the 3 laws for parallel. It's going to be very important for you to understand those before we move into these. This slide here, this slide basically shows you how a series parallel circuit is wired. Okay, there's nothing we're going to do here other than just look at this slide. We can explain it though. We can kind of go through how the circuit is wired. Okay, we have our power source, which comes off of this arrow here that goes back to the battery. So the battery's not shown. So I can draw a little battery right here and I put 12 volts here. And there's our positive. Okay. So that's how our battery would be. I'll put the negative over here to ground. Okay, so our positive comes off of this arrow down here, goes into the fuse box. Okay, so this is our fuse box, but also what's part of the fuse box in this case is our headlamp switch. Okay. When we go after the headlamp switch, we go into the headlight dimmer switch, and that is this switch right here. Now, this portion right here so far, which we've talked about, is a series circuit. Okay. From the power into the headlight switch into the dimmer switch. From there, it's completely series circuit. There's no breaks in between. There's nothing, no different paths for electricity to flow. All right, now this is where we start our parallel portion. Okay. Yeah, as you can see, there's a junction right here, which I'm circling or highlighting. And there's another junction over here. Now, these junctions represent different legs. So we have one leg here, one leg here, one leg here. We have, looks like 4 legs within 2 separate parallel types of circuits. All right, so this is how we're looking at it. So we have a series portion in the beginning, which is usually how everything starts. Then we have a parallel after the series portion. And then these are 2 separate parallels on 2 separate switches. Okay. And that's how we would look at this. And that's all we're doing for right now. We're just trying to look at this diagram to try and figure out how it's wired. Okay. This circuit, this whole PowerPoint, there's a lot of math involved. So we're mainly just going to do math problems. And we're going to combine series circuit laws with parallel circuit laws. And we're going to work with them together. All right. So this one, we always got to find the same 3 things as usual. So we have to find E. I'm going to write them down at the bottom. E, we have to find I. I'm going to put a T next to the I for total. And we have to find RT as well, resistance total. Okay, some things are given, some things are not. In this specific circuit, the E is given. So we have 12. Okay, we have 12 volts. The I is also given, which is 3. Okay, so we have 3 amps. Now, before we even proceed, we could easily find RT with just those 2 numbers. Okay. Luckily, in this circuit here, all the numbers are given. It's just showing you an example of how to do it, but we would be able to find total resistance to equal 4. Sorry, that was putting the wrong letter there, but 4 ohms. Okay. Total resistance is 4 ohms. So how did we get that though? Now, and where's our series and where's our parallel? So in this circuit here, we have a junction at the very top, which I am highlighting. And then we have a junction at the bottom, which I am also highlighting. So in between those 2 junctions are our parallel circuit. So one leg goes to the right and one leg goes down. Okay, but within our, let's call this leg 1 over here, and let's call this leg 2 over here. Within this first leg, leg 1, we have 2 resistors. Now, is there a break between resistor 1 and resistor 2 along this wire? No, there's no break. Okay, so what that means is that these 2 resistors right here, they are wired in series. So we're going to take L1 and put it over here to the side, but L1 equals 4 because the law for series circuits with resistors is to add them up. L1 equals 4 plus 4. So L1 equals 8. Okay, So L1 equals 8. Now let's go over here to L2. L2, there's only one resistor, so that's easy. So L2 also equals 8. Now, since we have two legs, what we have to do is the equation for total resistance with two resistors, which is RT equals R1 times R2 over R1 plus R2. Basically, it's 8 times 8 over 8 plus 8. Okay. And 8 times 8 is 64. And 8 plus 8 is 16. If we do 64 divided by 16, we would get 4. And our answer is indeed 4 ohms of resistance. Okay. So hopefully that explains a little bit on how to work these problems out. We're going to do a couple more. And then I want to make sure that everyone has a chance to try them by themselves. And if you have any help, as always, make sure to reach out to me. Okay. So this one here, this circuit, we are looking for R1. Okay. First thing we should identify is where is our series and where is our parallel. Okay. We have a junction here, and then we have a junction here at the bottom. So that's where our split is for our parallel. So our parallel portion's here and here. So one leg goes to the right and one leg goes down. So there's two legs over here. But the R1 is not part of this parallel. It comes before it. So that means that this R1 is in series, because if we follow the path from the battery across all the way over to the first junction, there's no break. It's just one single wire with the resistor inside of it. Therefore, R1 is the series circuit in this circuit. Okay, again, as far as our E is concerned, our E is given, so that is 12 volts. Our IT is given also, and that is 3 amps. Now we can find the RT. Okay, IT was given and E was given. Our RT, we know it has to be 4, because we can just use the two numbers that are given, which is 12 and 3, to be able to find RT. Okay, so that was easy, but that's not where we're all fully looking for. We're looking for R1. If we want to show this mathematically, I'm going to show you the formula that we could use if math works out for you. If you prefer the algebraic way, I'm going to do RT is going to equal, in this instance, R1 plus, this is where we put the equation for two resistors for a parallel circuit. R1 times R2 over R1 plus R2. Okay, if you want to put parentheses around this, you can, but it's not really necessary, because if we were just to follow normal PEMDAS, which is the order of operations, we would complete the fraction first. Okay, and this is where the fraction is. If you want to put parentheses around it to make to make everything look a little bit better, then we could do that as well. All right, but that would be our equation to find this. We can plug the numbers in. The only number we're missing is R1. That's it. Okay, we have 4. We don't know what R1 is. I'm going to do this portion in my head really quickly. Okay, because that would be 4 times 4, which is 16, and then 4 plus 4, which is 8. Okay, and if we can reduce this, this would be 2. So now we're left with 4 equals R1 plus 2. What number plus 2 equals 4? We can subtract 2 from both sides. I'm sure everyone can see this by now. Subtract 2 from both sides, we would get 2 equals R1, because these cancel out. That turns into 0. Okay, so 2 equals R1. R1 is 2, and that would be our answer up here. So our answer would be 2 ohms. Okay, so this one, again, not very difficult to figure out. We cannot do the same trick we can with common values uh, for resistance like we do in a parallel, and we cannot use the same trick as we do with amperage, because we're not adding amperages in this circuit. Okay, we are not adding amperages in the circuit. If we were just doing with a parallel, we could, but again, there's a series here, a series portion. In this instance, it is R1 that is throwing a little wrench in our calculations that we have to include. Okay. There are a few examples on this PowerPoint. I'm not gonna go through all of them because I do want you guys to try and figure out some of them on your own, because some of them were going to be on the test too. But I'm going to show you hopefully enough to where you can figure them out. Okay. And luckily the quizzes are multiple choice, so at least you get some idea. As long as you go through it and you get close, you'll know what the answer is. You at least have a 25% chance on all questions. So this one we're looking at here, we are looking for voltage. All right. Voltage is the one that's not given. So we're going to put our E down here. You can guess and put 12 volts, right? We could do that. But instead of doing that, let's just figure out the problem the way we're supposed to. All right. So our E is unknown. Our IT is 3 because that is given. And then our RT is unknown at this point. What we're going to do, though, is identify where our series are and where our parallels are. Okay, so we have our two junctions. That is the split. There is no resistor before the junction or after the junction. So which means there's no series before the parallel. All we have is one straight line from power over to the first junction. And then we have another straight line, straight wire from the closing junction back to ground. So there's no resistor within this area. So we're good. So what we have to look at now are the 4 resistors that we have. We have leg 1 and leg 2. So I'll put L1 and L2 over here. So leg 1, we have 2 resistors, and there is no break between the 2 resistors. So these 2 resistors are, in fact, in series. Okay, I'm going to put an S for series. These 2 resistors, exactly the same thing. They are in series, just like the other 2. So what do we do with 2 resistors in series? We add them together. Very simple. Okay, so in order for us to find RT, what we're going to have to do is add the 2 resistors. So L1 or the 2 resistors in leg 1, they're going to equal 8. And then we're going to multiply it by the other leg, which is 4 plus 4 is also 8. So it's the same thing. We're still using the same equation as we did with the 2 resistors to form a parallel circuit, because in fact these 2 resistors, even though they're separate, we add them together within each leg. So it'd be 8 plus 8. Okay, we've already done this in the previous slide, in the previous equation. So we know the answer already, 64 over 16, which is 4. Okay, so RT equals 4 ohms. Now, 12 volts. Okay, 3 amps times 4 ohms would give us 12 volts. In this case, if we would have guessed 12 volts, we would have got it right. But that is not always the case. So I don't want everyone to guess. Okay, it doesn't always work out to 12 volts in some of these equations. Let's go to this one here. Okay, this one's a little bit tricky. We're trying to find amperage. This will be the last one I show you, because I do want you guys to study on your own and try and figure these out on your own. There are some harder ones, but again, if we know the basics, if we know how to start with it, how to identify the series and how to identify the amperage, the parallel, then we should be able to figure these out. Okay, they do take practice. Again, this is the theory portion of electrical. After this, we do go into a little more practical understanding. We go into wiring and stuff like that. All right. Now, E is given, which is good, 12 volts. Okay. I is not given, and RT is not given. We will find that eventually, though. What are we looking for? We're looking for amperage. So that's what we need to find, is the amps. How do we start here? What can we do? So we have a bunch of different resistors, right? We have 4 total resistors, but do we have 4 total legs in a parallel? Hopefully you say no. Okay, hopefully, again, we're going to identify where the parallel is. I'm going to draw the junction. I'm drawing this one bigger so we can see where the first junction is and then where the second junction is. So we have our opening junction and closing junction, so to say. Within the two junctions are our parallels. So here's one parallel to the right and one parallel down. So we only have 2 legs. That's it, 2 legs in this parallel. I'll label them L1 and then L2 over here. But we have an R1 that is 2 ohms, and that is before the first junction. So that tells us that that R1, which is 2 ohms, is in series before the junction. Okay, so it's going to look very similar to two slides before. All right, so what we're going to do is to find our T, we're going to have to use the same equation, which is RT equals R1 plus, and then we're going to find, instead of doing an R in this case, what I'm going to do is I'm going to put L1 for leg 1. Leg 1 times leg 2 over leg 1 plus leg 2. Okay, so the reason I'm doing this here is because, let me clean it up a little bit, is because we have 2 resistors in leg 2. Okay, I don't want to put R1, R2 because we have 3 resistors to account for. And how are we going to add these 2 resistors within the equation? How are we going to include them? So I want to make it a little bit more clear in this instance on how we're going to include these resistors. Now we can plug the numbers in really, really easily. Okay, RT equals 2 plus L1. L1 only has 1 resistor in it. Okay, L1 only has the 8, so that's really easy. So 8 times, now over here, we have 2, over here in L2, we have 2 resistors. They're both 4. Now, is there a break between the 2 4s? There's no break between the 2 4s. So this portion of L2, just L2, is a series circuit. So in a series, what do we got to do? We got to add them up. So we're going to add 4 plus 4 to get the value of L2, which is 8. Okay. So L1 is 8 and L2 is 8. So now we can finish plugging these numbers in. And then we can complete almost, I'll do it in 2 more steps. R2 equals 2 plus, oops, sorry, no, that's multiplication. Let me rewrite that. Plus 64 over 16, which we know from the previous slide that that is 4. Okay, so RT equals 2 plus 4, which is 6. So we have 6 ohms of total resistance in this circuit. Now, let's finish the problem, because what we're actually trying to find at the end of the day is amperage. So 12 volts divided by 6 ohms, 12 volts divided by 6 ohms will give us 2 amps. Okay, and that's our answer. So that's what we were looking for originally, and that's how we found it. Okay, by going through this process. So if you have to pause the video at any point, feel free to. I always encourage you to. If you have any questions, please reach out to me. There are additional questions, additional problems on this PowerPoint, and you are welcome to go through them. I would encourage you to try to practice. And so hopefully you can get the answers on the quizzes. And again, if you have any issues, or any questions, please reach out to me. Okay. So thank you very much, and hopefully you have a good one.